When you live in a country like Canada, where for the most part the sidewalks become ice rinks in the winter, the chances of you falling and hurting your back become pretty high. The misfortunes of our winters aside, whether it's due to a car accident or even while playing sports, 1 in 3 Canadians are likely to suffer from a spinal cord injury before the age of 65. Every year, there are up to 500,000 reported cases of spinal cord injuries, with these people twice as likely to being rehospitalized and up to 5 times more prone to dying prematurely. These facts are spine-chilling, especially when we realize that up to a third of you will potentially be undergoing spine surgery for one reason or another in your lifetime. Now, if that isn't scary enough, here's the catch. Surrounding our spinal cord is a type of fat known as epidural fat, and up until now, spine surgeons commonly consider it to be a space-filling and biologically inert tissue. As such, they will routinely discard it in attempts to increase their operational field of view. Recently, however, a functional population of stem cells was discovered within epidural fat. Now, stem cells are like the blank tiles in a game of Scrabble. These tiles are powerful and can be any letter you want. Similarly, in our bodies, stem cells can become any cell type and have the power to modulate tissue maintenance and repair. This finding, therefore, begs the question, should epidural fat be removed from the body during surgical procedures? And is it really an insignificant tissue if it contains cells that can improve our outcomes post-surgery? My master's project aims to find the role of these epidural fat stem cells within the body and to investigate if and how these cells can respond to injury. Using a genetically modified mouse model in which the epidural fat stem cells are fluorescently labeled, I can track their movement over time as well as their response to an injury in their local environment. So far, I have found that throughout growth, stem cells from the epidural fat migrate towards and enrich the dura mater, which is a protective membrane surrounding our spinal cords. Moreover, when I puncture the dura mater, stem cells are found at the site of injury. These results indicate that epidural fat is likely not a dispensable tissue, as it contains the very cells that can make all the difference in growth and in healing. Overall, my project emphasizes the importance of revisiting that commonly held perception of epidural fat as irrelevant and suggests that spine surgeons adopt protocols in which epidural fat is preserved. Now, whether we end up in surgery due to an injury or even because of back pain, it's important that we walk in knowing that epidural fat, a potential source of both repair and regeneration, has literally got our back.